Hey everyone, thanks for tuning in to Crops TV. My name is Ryan Hamburg. I'm a graduate research assistant at Iowa State University. Today we're going to be talking about the frequency and distribution of herbicide-resistant water hemp in Iowa. So starting off, I just want to give a little bit of background into the history and the problem that we're facing today with herbicide-resistant water hemp. What's interesting is it wasn't considered a significant agricultural weed in Iowa until the early 1990s. The image on the right here, you can see the dates at which agronomists in each state started to notice water hemp becoming a problem. And you can see that in southern Iowa, it started to become a problem in about 91, and then in northern Iowa in about 1994. If you fast forward to today, it is now considered the most common and troublesome weed in Midwest soybean fields. And that's according to the WSSA, which put out a survey in 2019. And there are a lot of factors that contribute to water hemp's rise to prominence. Namely reduced tillage or no-till practices, which have caused growers to become increasingly reliant on herbicides for weed control. Also the fact that water hemp is incredibly genetically diverse, and so it has a lot of differential susceptibility to many of the herbicides we apply, as well as one of the biggest factors, the ability to rapidly evolve resistance to herbicides. So starting off, I just kind of wanted to show a timeline of the history of resistance in water hemp. And you can see that dating back 3 decades now, the first confirmed case of resistance in the species, we have group 5s or the triazines. And then within a couple years, we saw resistance to ALS inhibiting herbicides. And then from then on, about every 5 or 6 years on average, we're seeing new cases of resistance pop up to different sites of action, all the way up to just a couple years ago with the first confirmed case of dicamba-resistant water hemp in Illinois in 2021. And then next, I wanted to kind of showcase, a lot of times when we talk about herbicide resistance within water hemp, it's not very likely that it's only resistant to one herbicide. A lot of the times, these populations we're dealing with are resistant to multiple herbicides at one time. And I just wanted to showcase the history of multiple herbicide-resistant water hemp throughout the last few decades. Starting off in 1996, we had 2-way multiple herbicide-resistant water hemp. Fast forwarding to 2018, there's now populations of water hemp in Missouri that are resistant to 6 sites of actions at one time. So first off, I want to talk about the justification for this research, or why we set out to complete it. And first off, we wanted to detect resistance as early as possible. That way we can be proactive and implement resistance management strategies. And then secondly, it's important we start to understand how resistance evolution is happening over time or temporally, particularly within a geographical region like Iowa. That moves us into our objectives. So at the start of this project, we had 3 main objectives. First being to evaluate the frequency and distribution of herbicide-resistant water hemp in Iowa. We want to see what's out there in terms of glyphosate resistance or some of these very important herbicides. We want to get an understanding of how much resistance is out there. Second objective was to evaluate the temporal changes over 6 growing seasons. Again, talking about how resistance evolves over time. In this case, we're looking at 2013 to 2019. Has the frequency of resistance increased, and how much has it increased over those 6 growing seasons? And then lastly, we wanted to look at the inherent response of these water hemp populations to glufosinate, 2,4-D, and dicamba. That's because over the last few years, there's been an increased use of these herbicides, and we kind of wanted to get the baseline understanding of what type of tolerance is out there with these water hemp populations. So now we move into how we set out to collect these water hemp samples. This project actually starts a decade ago when Dr. Mike Owens set out to collect 100 truly random samples of water hemp populations across Iowa. And I want to emphasize the aspect of that they're truly random, because a lot of times with herbicide resistance surveys, they're not picked randomly, or they're arbitrarily picked, or a lot of the times they're sent in by farmers who are already having a problem. The problem with those types of surveys is you're not able to make broader generalized conclusions of the resistance in a particular area. So with this truly random sampling method, it allows us to make a broad assumption of what type or how much resistance is within Iowa. So he collected 100 populations across the state and screened them with 5 of the most commonly used herbicides in corn and soybean. If you fast forward to 2019, we set out and revisited those locations that were geo-referenced, meaning we had GPS coordinates of all those locations, and we collected again the same 100 populations from soybean fields, as well as making collections in 100 nearby cornfields. We wanted to get an understanding of how the crop that's present at the time may affect the resistance profile of those water hemp. So again, we collected 200 populations of water hemp in 2019. We then grew those populations of water hemp in the greenhouse and screened them with 8 different herbicides, 5 of which, as I mentioned, were part of the 2013 survey, those being imazethapyr, atrazine, glyphosate, lactofen, and mesotrione. And then to meet objective 3, we also screened them with glufosinate, 2,4-D, and dicamba. For each herbicide, we applied 2 different rates. Except for glufosinate, 2,4-D, and dicamba, we only applied the 1x rate. The 1x rate being the field use rate, or the rate that the farmer would apply in the field, and then the 4x rate is 4 times the field use rate. For each herbicide rate, we selected 30 plants approximately 3 to 4 inches tall and sprayed them. Data collection consisted of percent visual injury, which we recorded 21 days after application, and then we came back a week later and took a binomial response at 28 days after application. A binomial response is essentially looking at each individual plant and making a determination if it's dead or alive. And the way we determined that was based on the visual injury rating. If the plant exceeded 65% injury, we would consider that plant dead. And the reason we did that is because at that level of injury, we determined that it would not be able to reproduce and contribute to the seed bank. So once each plant was rated as either dead or alive, we then decided whether the population was resistant if the survival frequency exceeded 50%. So if 50% or greater percentage of plants survived that application, we considered that population resistant. And that's because at that level of survival, it'd be very noticeable in the field and also create a management challenge for the grower. Now we can move into the results and discussion of this research. So starting off, we're looking at the frequency of herbicide-resistant water hemp in Iowa, and this is at the 1x rate. Along the y-axis, we have the percent of populations, and the x-axis, we have the herbicides. The green bars represent the 2013 data, and the orange bars represent the 2019 data. And what you can see right away is that for all 5 herbicides tested, the frequency of resistance actually increased. However, I want to kind of bring more focus to glyphosate, PPO, and HPPD. We can see that from 2013 to 2019, there was a large increase in the frequency. For instance, in glyphosate, about 67% of populations were resistant in 2013. That jumped up to about 90% in 2019. And with PPO, we saw that none of the populations were resistant in 2013. However, that jumped to about 13% in 2019. And then looking at HPPD, we can see 6% were resistant in 2013, moving up to about 16% in 2019. And again, this is survivors to the 1x rate of these herbicides. So 90% of populations were glyphosate resistant. That's a pretty significant margin there. So the second graph is the same type of information, except we're looking at the 4x rate. Again, what I want to focus on is glyphosate, PPO, and HPPD. For glyphosate, we saw an increase of 25% of populations in 2013, moving up to about 60% of populations in 2019. It's important to emphasize this is 4 times the field use rate. So these populations are surviving 4 times what the farmer would be applying in the field. And again, we see PPO and HPPD, we're looking at an increase to about 2% and 3% of populations resistant to the 4x rate. This next slide, I just kind of wanted to show some images of the plant's response to both PPO and HPPD. We're looking at populations that were treated with PPO and HPPD 21 days ago. And you can see that there are some plants that have been controlled, but there are also plants that are regrowing. And you can still see the symptomology of the herbicide. For instance, with HPPD, you can see the bleaching commonly associated with those chemistries. But again, what I want to emphasize is that after 21 days, these populations are showing regrowth and are going to survive. And so this is what a resistant populations will look like 21 days after application. So now we're moving into the frequency of multiple herbicide-resistant water hemp, and this is at the 1x rate. Similar graph where we're looking at the percent of populations on the y-axis and the multiple resistance along the x-axis. And what's interesting about this data is the fact that we're looking at a shift happening over time where populations that were once one-way and two-way multiple herbicide resistant are becoming three-way and four-way. In other words, populations of water hemp are increasing in the number of sites of action they're resistant to over these 6 growing seasons. And you can also see that the majority of populations of water hemp in Iowa are resistant to 3 sites of action at once. And we also had some populations that were 5-way multiple herbicide resistant. As you start to stack these resistances, these populations become an increasingly more difficult to manage. And in some cases, when you're looking at 4-way and 5-way, the grower is essentially running out of herbicide options in the particular crops they're trying to control these weeds in. Moving to the 4x rate, similar graph here, the same story can be shown where populations that were once 1-way and 2-way are becoming 2-way, 3-way, and in some cases 4-way multiple herbicide resistant. What's also interesting is that in the 2013 data set, we had a large proportion of populations that were completely susceptible to all 5 herbicides at the 4x rate. However, that decreased pretty drastically with only one population in 2019 that was completely susceptible to all 5 herbicides. And again, this is 4 times what the rate that the farmer would be applying in the field, so it's pretty alarming. Okay, moving on to the distribution, we wanted to showcase how these resistant populations are spread across the state of Iowa. Here we're looking at 4 of the herbicides tested. We removed ALS herbicides because almost 98% of the populations were resistant, and you wouldn't really see any sort of pattern. That being said, with glyphosate, PPO, and HPPD, we can see no real patterns. Glyphosate resistance is pretty evenly spread across the state, with PPO and HPPD not very spread, but occurring kind of in random locations across the state. What's interesting about atrazine, however, is it looks like in that north-central region of Iowa, there's no cases of resistance, at least in our data set. That could be because of the higher pH soils in those regions, which farmers may not be applying atrazine due to carryover concerns. However, that goes beyond the scope of this project. It's just something we've kind of noticed. Here we can see the distribution of multiple herbicide-resistant water hemp in Iowa for the 2019 data set. And again, what we see here is that it's pretty spread across the state. There's no real pattern to be observed. It's just randomly spread across the state. Okay, so moving on to the response to 2,4-D dicamba and glufosinate. As mentioned, we wanted to look at the inherent response of the water hemp populations to these herbicides because of their increased use over the last few years. The good news here is that none of the populations we screened survived dicamba or glufosinate at greater than 50%. However, we did have some populations that had some survivors, 20 to 30% survivors, but none of them met that 50% threshold. The bad news here is that we did see 8% of populations survive 2,4-D at a 1x rate. We did actually take those survivors and plant them in larger pots, and they ended up producing seed, and we plan on taking that seed and investigating those resistances further. So, wrapping up here, in conclusion, what can we take away from this survey? Well, first off, resistance to ALS, PS2, and glyphosate is widespread and frequent within the state of Iowa. Frequency of resistance to PPO or HPPD herbicides is relatively low, but it did increase over those 6 growing seasons. And then lastly, we can see that multiple herbicide-resistant water hemp populations are increasing. We're seeing some of these populations increase in the number of sites of action they're resistant to. So, what are some of the implications of this research? It seems apparent that diversified cropping practices are warranted in order to reduce selection pressure. Multi-tactic strategies are needed in corn and soybean rotations, starting off with things like diversified herbicide programs, starting clean, incorporating a pre-emergence herbicide with a residual, coming back with a strong post program. Make sure you're applying multiple effective modes of action. So understanding if you have resistance in your field, what resistances are present so that you can ensure you're applying effective herbicides. We've also done a lot of research here at Iowa State utilizing cover crops as a weed management tool. We've seen that delaying the termination timing of your cover crop can do an excellent job of suppressing and reducing water hemp biomass, thus increasing the window of opportunity to apply your post herbicides. And we've also seen that a lot of the times the weeds are smaller when you make that post application, which allow your herbicides to be more effective. We also have data and research we've conducted at Iowa State looking at narrow row spacing. Just reducing your row spacing from 30 to 15-inch row soybeans, for instance, can do a good job of suppressing and reducing water hemp biomass. And then lastly, we've done a lot of research in the last couple years utilizing harvest weed seed control. That's where we target the weeds at the time of harvest, either through chaff lining, which is where you concentrate those weed seeds into a narrow row behind the combine, or looking at a seed destructor unit that actually destroys the seeds that enter the combine. And we've noticed that they're very effective, and they do a good job of reducing weed seed incorporation into the seed bank. With that, I'd like to acknowledge my colleagues and the technicians, as well as my advisors who helped me in conducting this research. I'd also like to thank the funding agencies, Iowa Soybean Association and Bayer Crop Science, for all their funding, which help us accomplish this research. Thank you.